Hello, welcome to another module in this massive open online course on the principles of CDMA, MIMO, OFDM wireless communication systems. In the previous module, we have seen how the IFFT operation at the transmitter, FFT operation at the receiver, and the addition of the signal prefix converts the OFDM system, helps convert a frequency selective wireless channel into n parallel flat fading channels in an OFDM or an orthogonal frequency division multiplexing system. To summarize this entire process, let us now look at schematic diagrams for the operations at the transmitter and the receiver in an OFDM wireless system. So, what we are going to look at today is we are going to look at the OFDM schematic, that is the schematic diagrams, a schematic representation, that is what we are going to look at is schematic representation of operations at transmitter and receiver in OFDM. That is, what is the sequence, that is, what are the operations and what is the sequence in which these operations are carried out in an OFDM system at the OFDM transmitter and the OFDM receiver. We are going to look at the various operations at the block level, what are the inputs to these various blocks and what are the outputs from these various blocks. Alright. So, let us now look at the transmitter schematic. In the transmitter, we begin with we have a set of symbols. These are x0, x1, xn minus 1, which are basically loaded onto the subcarrier. So, what do we have is we have a serial symbol stream x0, x1, xn minus 1. We are going to convert this to a parallel stream, that is, this is a serial to parallel operation. This is serial to parallel operation. This is also known as a demux or demultiplexing operation, which is basically to load the symbols onto the subcarriers, to load symbols onto . So, we are starting with a serial to parallel operation. We have a serial symbol stream of the capital X's, that is capital X0, capital X1, capital Xn minus 1. These symbol streams is converted into a set of parallel symbols x0, x1, xn minus 1 to load them onto the various subcarriers for the IFFT operation. This is also known as a serial to parallel conversion or a demux or a demultiplexing operation. Alright. So, demux stands for demultiplexing. So, let me write this in brackets, demux stands for the demultiplexing. After this demultiplexing or serial to parallel conversion, I now have these n symbols which are loaded onto. What I have is basically I have these n symbols which are loaded onto the n subcarriers. So, here I have the various symbols and then I am going to take the IFFT of these symbols. So, this is an n point IFFT of the symbols x0, x1, x2, xn minus 2, xn minus 1. I am taking these symbols x0, x1, x2, so on up to xn minus 2, xn minus 1. I am loading them onto the subcarriers. I am taking the IFFT, the inverse fast Fourier transform of these symbols to generate the transmit samples which are the small x0, small x1 up to small x n minus 1, remember, alright. So, you can recall, you might recall that these then generate the transmit samples. We now generate the transmit samples. That is, now what we do is we generate the transmit samples So, we generate the transmit samples which are x of 0, small x of 0, small x of 1, small x of 2, so on until small x of n minus 2, small x of n minus 1. These are, what are these? These are the samples. These are the samples or the transmit samples, correct? These are the transmit samples. Now, these are now again converted back to a serial stream, that is a P by S. You use a parallel to serial converter, and this operation is also known as, this is the inverse of the demultiplexing operation, this is also known as a multiplexing operation. So, after the IFFT you have the samples, the transmit samples, small x 0, small x 1 up to small x n minus 1. You pass these to a parallel to serial converter, which is also known as a multiplexing operation or a MUX, to generate the serial stream small x 0, small x 1 up to small x n minus 1. So, what you do here is you generate your serial transmit stream. So, what I am doing here is I am generating my serial transmit stream, that is the small x 0, small x 1, small x 2, small x n minus 2, small x n minus 1. This operation is known as multiplexing, and now I am going to add the cyclic prefix, that is Cp, or I am going to add the cyclic prefix to this. Once I add the cyclic prefix to this, what I am going to have over here is I am going to have x of n minus L bar up to x of n minus 1. This is the cyclic prefix, followed by x 0, x 1, x of n minus 1, which is the original block. And now these are, so this what I have over here, this x of bar of x of n minus L bar to x of n minus 1, this is the cyclic prefix, this is the cyclic prefix. And now what you are going to do is, now these samples, these are transmitted over the, these are transmitted over the channel. So, what we have is, we have our samples small x 0, small x 1, small x n minus 1. We are going to add the cyclic prefix of L bar samples, that is x of n minus L bar, x of n minus L bar plus 1 until x of n minus 1. This is prefixed before the original block, that is small x 0, small x 1 up to small x n minus 1, and this is then transmitted over the wireless channel. So, this is basically after the addition of the cyclic prefix of length L bar samples, where L bar is chosen appropriately, this is transmitted over the wireless channel. This is the OFDM signal which is transmitted. Okay. So, this is also known as the transmitter schematic, correct. So, this is basically the sequence of operations which is carried out at the transmitter. This is also known as the transmitter schematic. So, this part, if you can look at this part, this whole part, this is known as the transmitter schematic or the TX schematic. The schematic representation, a schematic representation of the operation or a sequential representation of the operations at the transmitter, showing the various inputs and the outputs to the various blocks and the sequence of operations that have to be carried on at the transmitter. Let us now look at the corresponding operations at the receiver of this OFDM system. So, let us look at the receiver schematic of this OFDM system. So, in the OFDM system, I receive the samples from the channel. So, I receive samples from the wireless channel. So, I have samples which are received from the wireless channel. What I am going to do is, first I am going to remove the cyclic prefix. So, this module is basically going to remove the cyclic prefix, because remember the samples in the cyclic prefix are affected by the inter-block interference. Samples in CP or cyclic prefix are affected by inter-block interference. So, after we receive these samples at the receiver, the first thing that we do is to remove the outputs corresponding to the cyclic prefix, because these samples in the cyclic prefix, they are affected by the inter-block interference. So, we remove the L bar samples, output samples corresponding to the cyclic prefix, and we take the rest of the samples, that is 0 until n minus 1 corresponding to the original OFDM block. Alright. So, this avoids interblock. This is how we eliminate interblock interference at the receiver in this OFDM system. This is then followed by, so now at this point we have our samples y0, y1 up to yn minus 1. Now, what we do is again we carry out a serial to parallel operation. So, this is serial to parallel operation, as we already seen. This is also a demux or a demultiplexing operation, and at the output of the demultiplexer, what we are going to perform after the demultiplexing, basically we are going to perform the FFT operation at the receiver, and obviously this is your endpoint FFT operation, and what you have as the input to the FFT are basically your samples, received samples y0, y1 up to yn minus 1. You are performing the endpoint, that is, these are the output of the demultiplexer, these are input to the FFT, that is endpoint FFT block, and then at the output of the FFT, obviously what you are going to get is, you are going to get on each subcarrier, you get the output of the corresponding, that is the, you get the capital Y of 0, capital Y of 1, so on, capital Y of n minus 1. Remember, the capital Y of 0, capital Y of 1, so on, capital Y of n minus 1, these are the FFT of the sequence received samples y is small y of 0, small y of 1 until small y of n minus 1. Now, what we are going to do to these samples is, from these samples on each capital Y of k, we are going to detect. So, this is a module, this is a detection module, detection of symbols. Using each capital Y of k, we are going to detect the transmitted symbol x y of k, and what we are going to have here is, basically we are going to have the detection module, and therefore, what we have at the output of our detection module is, we have the symbols that are detected these are the symbols that are detected, which are the capital X hat of 0, the capital X hat of 1, so on until the capital X hat of n minus 1. These are the detected symbols. So, these symbols are basically, these are the detected symbols, and observe that X hat of k is not necessarily equal. We are denoting the detected symbol by X hat of k and not X of k, that is capital X of k, because the detected symbol capital X hat of k need not be equal to the transmitted symbol capital X of k. There can be errors in the detection, and this is where we have bit errors in the OFDM system, right. So, we are denoting the detected symbols by capital X hat of 0, capital X hat of 1, so on up to capital X hat of n minus 1, where each capital X hat of k is the symbol detected on the subcarrier k from the corresponding output of the FFT, that is capital Y of k, which is the kth FFT coefficient of the received output samples. Okay. And now finally, once we have detected these symbols capital X hat 0, capital X hat 1, capital X hat n minus 1, all that is left is I have to do a parallel to serial conversion, that is I have to do a mux or a multiplexing operation to basically convert these back. These are now converted back to my serial stream, that is X hat 0, X hat 1, X hat n minus 1. So, this is my serial symbol stream. So, this is my serial symbol stream which has been generated, and what this is, again this is the sequence of operations that is carried out at the receiver. Therefore, this is the receiver schematic of the OFDM, or also which we can call as RX. The receiver schematic. So, what we are seeing in this receiver is basically, initially we start with the removal of the cyclic prefix, followed by the serial to parallel demultiplexing operation, followed by the endpoint FFT, followed by the detection of the symbols on each subcarrier, followed by the parallel to serial multiplexing to generate the serial symbol stream X hat 0, X hat 1, X hat n minus 1. This is the schematic of the receiver of the OFDM receiver. So, what we have seen in this module is we have basically seen the transmitter schematic, that is we have seen the sequence of operations, the various modules in the transmitter, the input to each module, the output to each module, until the transmit stream, that is the samples that are transmitted across the channel in this OFDM transmitter are generated. Subsequently, we receive these samples at the receiver, and at the receiver we have also illustrated the receiver schematic, which is a block level system diagram of the various modules in the receiver, the sequence of operation of these various operations at the receiver, the input to each module at the receiver and the output to each module, until we recover the transmitted serial symbol stream, that is the capital X hat 0, capital X hat 1 until capital X hat of n minus 1. So, this schematic representation of the transmit and receive operations in the OFDM system helps clarify a lot of this, that helps succinctly summarize these various modules and the various operations in this OFDM wireless communication system, thereby also giving you a convenient pictorial representation, something that is easy to remember, something that is easy to recollect with respect to this OFDM wireless system. So, we will stop this module here, we will look at other aspects in the subsequent modules. Thank you very much.